Hello and welcome back to the channel, everybody. Chapter 5 of the Niles Bement Power Hammer Saga. Thanks for tuning in as always. Now, what you see here is a picture of the lower die for the Niles sitting on my 172-pound Peterite anvil. So you get a picture of kind of the scale of that bottom die. It's chunky. An interesting thing to note right here before we get into it, the die itself is kind of sitting on top of a raft of medium carbon steel that was later welded to it, I believe. Here you can see it's kind of on the right, which is the bottom surface of the die in this picture. That is not original. If you look above that slab of steel on the bottom of it, the die, original die there, what I believe to be, has a smaller footprint and is sitting on top of it. And I think that contributed to some of the problems we'll get into fixing in this video. You can see the smaller size of the original die footprint kind of corresponds to some of the issues in the sow block. So I think that this was a relatively well conceived effort at increasing the footprint and surface area of the lower die to mitigate some of the problems, albeit somewhat belatedly. Anyway, I'm sure you've noticed by now that large crack staring us in the face. So without further ado, let's get into talking about that and addressing that problem.
Behold, a problem. This is going to be a pretty significant repair. So this is the lower die for the Niles Bement steam hammer. You can see that it has got a big nasty crack all the way up through the dovetail. Not largely up into the die surface or anything, but up into this shoulder. I can assure you that the other side looks just as bad. It's cracked through almost to the top of this web and about ready to bust off. So that is about 2.5 inches of dovetail there, about ready to bust off. Why that happened? Check it out. There is a declivity in this lower female dovetail in the sow block that, when I got this machine, was partially filled with this like steel filled Bondo or some kind of metal filled epoxy putty looking stuff, and it was crumbling out. So I just put this together like this because I can get it to wedge pretty tight. And because this flat surface actually surfaces right here, so between here and here there's enough contact for a die, but all this is negative space still. But I figured with this big old thick lowered dovetail on the die, it would provide enough support. Well, obviously not so. What happens is you crack the shoulder off the die. So I'm going to have to V this way out with an abrasive wheels, get that welded with nice deep penetration and back to straight, and then I'm going to have to repair this dovetail, and I'm not going to fill it up with epoxy this time. That was a slipshod repair by someone to begin with, and it worked for a while, but it obviously doesn't work for the long term. So what I want to do is just put this up on the metal shaper, big old Ohio 28-inch metal shaper here, and let it earn its keep by remachining this down to flat, down to this, just below this level right here, the lowest part of the flaw. And then I'm going to have to take this surface down a corresponding amount, and that'll actually allow me to improve the dovetail surface contact, because there's like blown out top corners here and stuff anyway. So I'm going to turn this whole dovetail nicer on the shaper. Probably end up shortening this 1/2 inch and this 1/2 inch, and then we'll get 1/2 inch more clearance between our dies, which is fine. Weld that up, and then even if the weld is not 100% penetration, once it gets set on this newly machined flat surface and wedged in tight, shouldn't be a problem at all. So that is the plan. It's going to be a big enough project that I figured I would just do this beginning clip right now while I'm evaluating it and making a plan, and then I'll be putting more stuff in as I go.
So as you can see, I've got the die here over at my welding vise, and I'm preheating it with the oxyacetylene torch. Now off camera, I went in there with angle grinders and big cutoff and grinding discs and stuff, and really V'd out the sides and the bottom of that crack quite a lot, cut it in there as far as I could really get. There's a ton to fill up with weld metal. And it's important to get a really good preheat on this whole thing. I don't recall, I mean this was like 2 years ago at this point. I'm making this video in retrospect, so I don't recall exactly why I didn't go with the rosebud torch on this one. At any rate, I wanted to get the whole die up to at least 300 degrees in the localized area, maybe up to more like 4. Didn't have a temple stick or anything, just kind of going by feel and eye color. Figure it's a lot better to do it by eye than to not do it at all. And then the plan was I built this big clamp to kind of keep it all together and force it back straight for welding. And then I decided to weld it with stick actually rather than MIG, and go with 7018 electrodes for good strength and just burn it in nice and hot. So I'll just get done preheating this here, and then we'll go into welding. I'll show a little bit of that. Here I had it tilted on its side to kind of fill up the sides of that notch better once I'd done some work from the top. And gosh, I burnt up a big pack of 7018 on this. Like 5 pounds maybe. I don't know. Maybe more. Then just having to stop for a minute, let it cool, chip off slag. It's a 300 amp Arco welder. I'm welding it in DC, so they didn't really have anything but 100% duty cycle at this amperage. I think it was running about 130 or 40 amps. I can't really recall. But I did want to stop, chip off slag a lot, and kind of assess how it was filling in between passes. And there was just a ton of this, tumble it around, weld it a little bit, chip, assess, fill more, tumble it. Till I had built it back up beyond where the original surface would have been by a little bit.
Got it all welded up. Ground out. I'm gonna surface grind this thing after it cools down. That ought to be a way better repair than the original one done by whoever, whenever. Of course, it's totally wrecked in here. Grinder schmutz all over the floor. Rod stubs, grinders. So, yeah, I'm going to take a minute and clean all this up and let this cool off, and then I'll surface grind it.
So I got the saw block set up on the shaper table here for a change of pace. And the most creative way I could figure out how to really clamp it down the best and tightest was to stick a bolt in either side of the handling holes and then chain it down with some turnbuckles to the actual shaper table. And that actually held it really nice and tight. And then I was still able to scoot it around a little bit for angles and stuff with a hammer, so it worked out. Here I'm just kind of feeling the workpiece out. I'm taking a cut across the top, found the surface, now I'm just taking the high points, and then we'll progress to decking the entire highest surface down to an acceptable shape, and then we'll see how much we had to take off of that, and then go on from there accordingly. There you can see the guts of the old Ohio just kind of working away there. Very important to manually oil everything on these machines the entire time they're running. Keep them happy. It's fun to watch them work.
So you can see the problem that we had. The bottom of this dovetail is super uneven. Now, it could be a couple of things. This could be some really high wear over a long period of time of someone using a die in about the same spot and it getting more and more crooked over time with a loose key or something until it smashed its way deeper on that side, just flaking the cast iron out bit by bit. Or this could be a factory casting defect. You can see that there's a bump right here, and there was a bump right over here too that looked cast into this irregular bottom flat, and this really was like a flat angle kind of diving down in there, so those are clues that could also mean it was a casting defect. I'm not sure. At any rate, there was some kind of a weird like metal filled resin type product cast into here to flatten out the bottom of the dovetail. They had been cracking out, so I figured let's not do that again, and let's go ahead and just machine the whole bottom of this thing flat. The deepest part here was about 375 thou deep, so we just decked this whole bit 400 thou down, and we're going to deck the bottom 400 thou down too, just to get down a little bit below that bad surface. And that's the plan for now. I'm just going to rough the bottom out, and then once I get pretty close to the corner here, I'm going to stop on both of these sides, and then I'm going to tap this in a little straighter for this side, you know, tram the dovetail, and then just skim the surface of that dovetail, and then cut it down to the corner to the deeper depth, and then flip the cutter and do the same thing on this side.
So with the top decked down and then the bottom of the dovetail decked down a corresponding amount, now we've moved to recutting the actual tapered sides of the dovetails here to a nice cleaner state. We're going to have to do both sides, and I'll talk more about how I set that up and show that a little bit. Another view here a little bit later in the process. You can see I've developed a wider, cleaner face on that dovetail. And as I'm plunge cutting down to get that, so I'm manually feeding the compound here down with it set over at an angle matching the angle of the dovetail. I'm using a big like 1-inch bit of high-speed steel I got from my machinist friend Nick Watts up the mountain there. That's working out pretty well. Hand ground it to the shape I wanted with a little radius at the tip. I'll show more about that later. But a lot of it is just standing here babysitting the machine and making sure it's happy and cutting the angle that we want. Here's a big video section of just cutting away on this. I speeded it up to 6 times normal speed here, so we can get an idea of how it progresses without taking all dang day to watch it. It's kind of fun to watch it go. Just get whittled down there. Get down to the bottom there. Sweep the cast iron out. We're not cutting with any lube because it is cast. It has lots of graphite. Once we get down to the bottom, we're going to wind it back, set it over a little bit, and take a finish pass on it, as you can see. That's kind of how it went for hours and hours in the shop. So we got the one side cut. Now I'm setting up the compound on the machine and the cutter for doing the opposite side dovetail here. And I found what angle the dovetails were, like what degree of taper per foot. I can't remember what it was, but when I was actually setting it up on the machine, what I did was really find the best area of the dovetail, the least pitted and dinged up, as a surface to take a reading off of, and then used a dial indicator set in the actual tool post to kind of trim in along the face of the angle there to set the compound to. And that actually worked pretty well for setting the angles. As far as how deep I was going to cut, I didn't worry too much about that. I just cut them both until they were clean enough, because I was going to have to remanufacture a custom key for it anyway, so the width doesn't matter a super ton. I mean, unless you did something crazy like take a ½ inch off, and then you'd have to worry about die alignment maybe and shimming. But that really wasn't kind of the case here. Anyway, you'll see that I set the dial indicator up there with the plunger pointing toward the dovetail. I really wish this old machine had a clutch. It does not. So you kind of have to wind things with this little hand wheel to position the ram where you want it. It's a bit fiddly. I think I'm going to set it up with a VFD and electric clutch sometime soon when I get more time to spend on improving the shaper. But you can see there I'm starting to kind of wind the shaper up and down, or wind the compound up and down to take a reading off of the actual face. I think I'm like scraping paint or schmutz off of it right here just with the cutter, because it has not been machined yet and it is old and crusty. Here I'm just making some kind of big gross adjustments by using the dead blow mallet on a partially tightened compound there. Hear my son in the background calling to me about something. He had wandered over into the shop there.
Oh yeah? Think so?
You can see me beginning to realize there I need to make an even larger adjustment to the angle here. Cranking the table over, setting different preload on it.
What?
It's still moving a lot. Here's another thing that I had some success with just for rough setup. Putting a straight edge pressed against the side of the existing dovetail to project that angle out into space. Visually checking that against the side of the compound and then adjusting the compound in line with it just to kind of get the rough angle in the neighborhood, and then going with the indicator from there again. Just kind of took some experimentation here. I'm not a trained machinist. I just have machines and I've learned how to use them on jobs bit by bit. To me it's kind of intuitive, and I try to supplement my intuitive learning process with watching YouTube channels and reading books and just picking up things as I need to know them and learn them.
Hey, what are you messing with?
My son was 5 years old here at the time, and he's a dangerous guy to have in the shop unsupervised. There's just so much sharp and heavy stuff around, but I just love that he comes in there anyway to see what I'm doing and showing interest. Finally, success. Only about 1 to 2 thou movement over the entire thing averaged out, so I got it straight where I wanted to machine it. So now we're cutting away on the side of it. You can see we're landing a little bit on the leading edge and on the trailing edge of this cut with a big gap in between. The other part of adjusting the workpiece in to the machine that I didn't show is actually changing the orientation on the table in the horizontal plane by bonking it around and then running the indicator down the length of the machine's travel to make sure I'm horizontally straight with the cut that I need to take. So all in all, you know, took some fiddling around to get where I needed to be. Changing the angle of the cutter a little bit there, so I'm taking less surface area per cut, turning the point into the work a little bit more, and we'll have to readjust it over and find the surface again. Luckily this stuff isn't too critical on the old shaper and sow block here. Within a thou or two is generally good when done. Here's how it looked after a bunch more passes. You can see the round nose ground on that tool is nice in creating a bottom of a dovetail without a big stress riser there.
Got the shaper all put back together, vise back on the table, sow block back on the hammer. Looking good.
Busy day in the shop. I love it when I can get 2 or 3 machines working in auto mode. At the same time, I feel kind of like the sorcerer's apprentice sometimes, watching these machines just kind of cut away, drinking some coffee. Got the surface grinder there actually making money, grinding some Damascus billets. Got to do that all the time to keep the lights on while we're spending what time we can on side projects like the hammer. You can see in the background there that the shaper was just cutting away on the sow block as well. This is a glimpse into my shop 2 years ago before I had the forge hood up. Here we've got the welded up lower die over on the surface grinder, grinding the bottom in first, get a nice flat surface, and we'll flip it over and grind the top in so we can get the top parallel to the bottom. That's cleaning up pretty nice. You can see we got a couple of low corners there. Got my friend in the background there, Dylan, forging out a knife, student of mine. Meanwhile, I'm cutting a new key on the shaper because, as I mentioned before, the spacing of things with the die block changed a little bit. Once I had it back on the hammer, I had to scrap the old key and make a new, slightly wider new key. Here I've got wooden wedges fitted to the hammer. I've got the lower die back in with the new key. Was doing a little bit of forging to see how it worked. This is what it's all about right here. Just get and have fun, run the thing, and have it be a little bit better every time. Not perfect, but a lot better. You can see it wasn't rocking around, the anvil that is, with the additional wedges fitted. Here we're doing a forge weld of a stack of like 3 pieces of Damascus here on the hammer. And it's really doing some work. Look how quickly it knocks the height of this billet down getting that weld. I mean, knocked it down almost 50% in just a few seconds there, so it's hitting. Turning on the air there. Can't have the air on the whole time. Got to conserve it. The hammer's kind of leaky. Now this is the second heat on that same billet, same day. Still testing it out. Now you can see in this video that the actual die key is running out to the right and behind the die now, rather than I used to have it wedged in opposite to that in earlier videos. I've got it fitted up this way now, back to original. It fits well, and I had to do a bunch of stuff to kind of like adjust the sow block alignment with the frame of the hammer and get the front edge die alignment right. I'll have to talk more about that as well. So here's another thing that I ultimately decided to do with the lower die. I didn't have video of making this cut. I have a very nice bandsaw for this purpose, and I decided to take an 1 1/4 or 1 3/8 off of the die height. It didn't need to be as tall as it was, and I was losing some of the stroke of the hammer. It was kind of running choked up, not developing as much power as it ought to have. And I had a couple little surface cracks that I'd found surface grinding down into the top of the lower die at the corners from whatever. They were old. So I cut this much of the die off to fix the surface cracks and to actually get more throw of the hammer so it can develop more power. That die just didn't need to be that tall, particularly since it had that kind of slug of steel added to the bottom to increase the die footprint. So after this, I feel like the hammer opened up more and actually hit a lot more like it ought to. We'll show a couple of clips in conclusion for this video of it running with the shortened lower die, and then chapter 6 will deal with some of the stuff I've done with the linkage and control modes. Here it is running in recip mode with the shortened die. This is my friend and student Luke Mattern running it right now. He makes some killer knives too out of Gold Hill, Oregon. You should go check his work out. Anyway, you can see it's hitting very solid now, pretty controllable. And a better view of that shortened lower die. And I got the die alignment right, so they're aligned pretty well along the front edge of the dies there. That's important. Now this is interesting. You're going to see the single blow mode here. I modified the treadle linkage to allow this mode as well, and I'll show more about that in the next video. But right now it just has some throttle applied so the ram stays up, And now when I kick the treadle, it gives me a single blow. You can see I get a tall stack of Damascus in there to weld down a tall stack. After this, I'll be feather cutting. You could actually see this sequence of forging on this hammer in one of my chain feather chef knife builds, I believe. You can see how handy that is to be able to get hard single blows and kind of adjust the alignment of the workpiece to the hammer in real time while I'm forging it down. Very good for control. Anyway, thanks for watching, and we'll see you in Chapter 6.